Good evening, everybody. Good evening and welcome. It's nice to see people actually back at the Society. My name's David Marsden. I'm the chairman of the Weapon Systems Technology Group. I would like to just introduce Malcolm, but before we get to that, I just have a couple of notices I need to read out, I'm told. In terms of housekeeping, there will not be a fire alarm this evening. If the fire alarm sounds, it will therefore be real, and the designated assembly point is the paved and railed area at the junction of Hamilton Place and Piccadilly, beyond the Intercontinental Hotel. And RAeS staff will be on hand to guide you. If you have mobility or access issues, please make yourself known to a member of staff so that they can make the necessary arrangements for your safe exit. And please do not leave unmarked bags or other items unattended. Please switch mobile phones to silent. And the event is being recorded and will be available on YouTube later. After Malcolm's presentation, there'll be an opportunity for questions. Please use the microphone if you would like to ask a question. And the lecture will aim to close at 7 p.m. So, with those out of the way, Dr. Malcolm Claus is currently a senior lecturer in Aerospace, Astronautics and Space Technology at Kingston University London. He has over 20 years' experience in both industry and academia, working for a number of organisations within the UK and the US. Malcolm is currently responsible for overseeing the delivery across a number of pathways within both aerospace and mechanical engineering departments. Malcolm's earlier career was based on systems engineering and aerodynamics, with positions at Lockheed Martin, Special Projects Department, MBDA at Filton, Aerodynamics and Propulsion, Principal Engineer, Hunting Engineering, DERA, Hypersonic Wind Tunnel Test Program Investigation and Divert Jets for Kinetic Kill Vehicles, and as a postdoctoral researcher at the United States Air Force Academy, Department of Aeronautics. Malcolm is also a member of the Royal Aeronautical Society Weapon Systems and Technology Specialist Groups. So, without further ado, I will ask Malcolm to speak.
Well, good evening, everybody. As David has said, it's very good to see you all in person and not through a Teams screen. So before I start this evening, I'm going to do another announcement or a statement, which is as follows. So the following lecture is my own personal views and is not attributed to or linked with any other organisation. The material used in this presentation is from open sources, and any additional illustrations which have been included are for discussion points only. So, the object of the lecture this evening is looking at our concept and assessment for a UK flight test hypersonic capability. Now, hypersonics has gone through a bit of a renaissance period over the last few years. Especially when we start to consider the progress which some countries have made in that area, especially in their flight and demonstration aspects. The testing and the development of a hypersonic weapon system has now pushed hypersonics once more into the spotlight and is now deemed as a required capability. However, some of the demonstrations and other aspects that we've seen over the last few years has also indicated a possible lack of capability. Some of you who are listening to the lecture and obviously are here this evening may be currently working in the field of hypersonics, either within the UK or overseas. Whether you're working in industry or academia, you're well aware that hypersonics has a tendency to become in and out of vogue, lots of peaks and troughs, and that's certainly the way it has been, at least for the last 20 or so years. When we talk about capability, we have to decide what do we mean. Now, for many of you, you've probably saw the title of the lecture and have come to your own conclusion of what capability would tend to be. However, for this evening's lecture, capability refers to the ability to support, develop, maintain, and, as the title says, do a flight test program, if you like, for a given vehicle or vehicles. We need to consider what hypersonics means in terms of development from a number of perspectives, and we'll try and capture that this evening, particularly from government, industry and academia. We need to think about who is doing hypersonics, what are they investigating, and why this is of importance to us. Each of the stakeholders, i.e. government, industry and academia, have their own role to play. And that role is to help guide and advance UK hypersonics and make sure that the UK can contribute to this interesting, challenging and exciting field within aerospace engineering. However, it requires buy-in from all of the three stakeholders as mentioned above. So if we think about terms of government role, we need to try and identify what requirements are needed for such a system. What are we trying to achieve? What are we trying to pursue? It's also trying to link together the various departments within government, Ministry of Defence, RAF, Army, Navy, etc., joint services, for possible use of these types of systems. So basically, we need a clear direction on what the UK, when I say we, the UK, are trying to achieve with regards to hypersonics. As I've said, hypersonics, especially when I was working in the field, went through these peaks and troughs, came in and out of vogue. And because of this continuing changing policy, it's quite difficult for industry to start to allocate time, resources and funding, especially if it's going to be internal funding, to delivery of these type of projects. So with regards to input from government and end users, okay, RAF, etc., there should be a way to, if you like, guide the industry in terms of projects and R&D. When we say R&D, there are two types. We're talking about fundamental research, so things that we can do from a ground-based perspective, and also applied research, which for this discussion, we mean an actual flight vehicle in terms of being applied. Another aspect that we've got to think about, and this has come up a number of times in all of our lives, is obviously COVID and how that's impacted on our working requirements. But it also has led to changes in the way we work, and also has probably seen a number of people leave the industry. So when we talk about capability, we're not just talking about hardware, things like wind tunnels, CFD codes, things like that. We're also talking about people that can actually use these pieces of equipment, can apply the CFD or the heat transfer work, and be able to use the skills that they've got to push these projects forward. Again, aerospace generally is facing a little bit of I'd say recruitment crisis in terms of people studying. So again, you could also say that a flight test capability will sort of bring in like the space X factor, whereas these high profile sort of projects and programs will hopefully try and inspire and encourage people to study aerospace engineering and eventually move on into the industry. So we talk a little bit about that in today's sort of lecture. Where academia can come in is obviously through the teaching, both undergraduate and postgraduate, but it's also, as I said, doing the fundamental research which is required to support these types of programs, but also for training and development. That's obviously with current staff and also, you know, as I said earlier on, bringing new people in. So recruitment and retainment. It's quite important for all three sort of stakeholders to try and work together to achieve this. And unfortunately, if we want to build this type of capability, we've got to work together, not in isolation. So really the challenge is to actually define what sort of capability we want, what do we have already available, and to try and do this in terms of a lecture. There are some examples that have been presented today that we can actually try and focus on. That comes in the second part of this evening's lecture. As we said, having a flight test capability which can support a future hypersonics program provides the ideal opportunity to gain practical experience. Remember, there's only so much we can do in ground test facilities or CFD, etc., etc. We need to try and find out how these vehicles actually behave in real flight conditions, and get a clearer idea how we can actually validate some of the design tools that we use to move that forward. So in essence, having a flight test capability will allow us to step away from the CFD software and also move away from the wind tunnel lab and finally bring in the last chunk, if you like, of a hypersonics capability. Again, before I start, I would just like to point out that since the conception of this lecture, there's been a recent announcement regarding hypersonics, and that too will be captured in this evening's lecture. So without further ado, let's make a start. So, as I said, a nice little image there just for discussion purposes, or, you know, fills out a nice slide. So this is what we're going to look at today. We're going to have a look at some recent developments from the US, Russia, China, and also India. We're going to have a look at the US response. Now, those two smaller bullet points are quite important for our discussion on UK capability. We'll have a brief look at the Hypersonic Challenge, not too much. There'll be some examples of some aerodynamics and things like that, but just to set the scene. And then we'll move on to a UK hypersonic flight test capability. So we'll have a look at some current capabilities. We'll also look at possible organisation and structure. What options do we have, or what options does the UK have? And we'll have a look at a final sort of case study and then some conclusions. The purpose of this evening's lecture is to start the process of putting together a sort of a white paper with regards to UK hypersonic capabilities. So later on after it, please feel free to come and discuss those with me. So let's make a start. So recent developments, US, Russia, China, and also Indian developments. So from the US, we're now looking at some glide vehicles. So the US does have some experience, obviously quite a lot of experience within hypersonics. Their sort of latest vehicles that they're doing are things like the AHW and a previous glide vehicle that they tested, unfortunately, due to some issues we'll have a look at later, unfortunately failed. But that goes to show just how difficult it is to do these sorts of programs. Remember, when we talk about hypersonic capability, we're not just talking about, as I said, CFD and wind tunnels. The whole, so the whole of this system, okay, all of these elements need to work together as one. Okay, so it's a lot of systems engineering that needs to go into these programs. Even more so if you then decide to put some form of propulsion system on your vehicle, because then you've got to worry about propulsion integration and things like air intakes, etc., etc. So again, a lot of studies would need to be done. And again, the only way that we currently have to try and see how all of these can work together is by doing some form of, real-life flight test. So HTV, primary effort for the US between 2003 and 11, designed to glide at a very high Mach number, 20. 2 test flights were done back in 2010 and 2011. Unfortunately, the test flights were not a resounding success, mainly due to some control issues that then led to the structure or the aerostructure breaking up. So again, another important element for these types of vehicles, and again comes back to capability, is how good are your materials, how good are your manufacturing processes to build these types of vehicles. So this, in a way, was a bit of the wake-up call that the West received with regards to glide vehicles and hypersonics, and especially the progress that the Russians have made. So the Russians have also been looking at scramjets and hypersonic work for quite a while, but this was the first sort of program that they sort of made public in the best way that they can. So it was revealed by President Putin in one of his State of the Union addresses or Federal Assembly address in 2018. Main reason that they give is to avoid any US anti-ballistic missile systems. A number of test launches have been conducted. The last one was in December 2018, and I believe now this system, again, if you go by official releases from Russia, this is now operational. And it's launched from one of their larger ballistic missiles, an SS-19. Sorry, wrong button. SS-19. Okay. Now that's also being replaced by their new next generation long-range ICBM, which they call SARMAT. So similar to the HTV, this was going to be able to glide about Mach 20. So from the best sort of images we can, these 2 models were created via Janes, just to give you an idea of what this vehicle actually looks like. So as you can say, quite similar in some respects to HTV2, but also features sort of some vertical tails or small vertical tails, which is HTV does not. Again, if we think about how someone would use these, it obviously would be the best way to get the biggest bang, so to speak, for your buck would be to have for your launch vehicle to carry as many of these as possible. So this is just, if you like, an artist's illustration of how these glide vehicles could actually be used. Okay, so what we're seeing here in terms of this is the original test vehicle. This is possibly what could be done for SARMAT, their latest thing. Now, whether or not they would plan to use these vehicles as a like-for-like replacement for conventional RVs is still up for question. However, they've come quite a long way in a relatively short time. The other area that, again, was a bit of a shock to the West was obviously what's been going on with China. And China has been following quite an ambitious program in hypersonics, which has resulted in this DFZF. So this is the glider part of their missile, of their booster system, called the DF-17. So again, little bits were drip fed to the media about some of their work that they were doing. Again, very interested in glide vehicles, and some work was done showing some pictures undergoing some tests in a wind tunnel. So this is the actual report taken from the news broadcast, and again, here you see the blue sort of image trying to be a recreation of said vehicle. And they're sort of a lifting body combination. So again, they're very highly focused at this particular time, looking at glide vehicles. So to support their development capability, okay, they've used balloon drop tests. And again, at around the same time, some images appeared showing some balloon tests. And you might think, well, why would we want to do balloon tests with regards to hypersonic work? Well, again, if we've got one of our models and we've got a small rocket motor on the back, we could take our balloon system, our launch system, up to a given altitude, drop it, kick in our motor, and then we'll be able to achieve some level of Mach number that we will want. Again, if the vehicle is instrumented and we can report back things like forces, temperatures, etc., that would feed into your overall development program. And it's quite a useful way to gain information at a relatively low cost. Okay, we don't have to worry about large-scale boosters. We're only really concerned with the manufacture of these drop test models. So again, there's 3 different types that they were looking at. So all of this work fed into this DF-17, and again was shown back in October 2019 as a new potential glide vehicle. Now, unlike the Russian system and the US system, this is a much, I'm going to say, slower vehicle, okay, only going to about Mach 10. But development of these sorts of systems has now caused a knock-on effect. It's not only the US, the West, that's concerned about hypersonic capabilities, it's also regional powers. And one of those regional powers that are very interested in what the Chinese are doing is India, and we'll get onto them in a moment. I'm jumping the gun slightly. But essentially, China wants to try and match, and if possible, surpass the US capabilities in hypersonics, not just hypersonics, but also things like access to space. Okay, and they've actually done some further demonstration of that work on their capabilities. So many of you may be aware of seeing in the press that there was a lot of fuss kicked up in October of last year about the testing of a fractional orbital bombardment system. So basically having a vehicle that would be in space and could then just drop warheads on you whenever it liked. So there was quite a lot of discussion, again, in open sources and things like that about that. So a number of sources have picked up on that this was another test of an HGV, but what was different to the previous test was the ejection of a secondary object or secondary payload. Now again, it's not clear at the time what that payload was or what it could mean. However, there are various ideas of what it could be. They range from things like a submunition to an air-to-air defence missile, so a missile to defend it against your incoming interceptor, or just simple countermeasures. The fact that they may have been able to eject anything at Mach 20 is interesting. No matter what its actual role is, the fact that they've got it to work or to do something poses overcoming of several challenges. And again, I would have thought many of you here who are currently more active in the area would probably have paid particular attention to these sort of comments. However, officially, it was nothing of the sort. It was just to verify technology for a spacecraft's reusability. So, we said regional powers. The main one that's doing a lot of hypersonic work is India. Okay, a lot of their work is developed with Russia. So this is their latest cruise missile that they're working on, the BrahMos 2, to replace the first generation or supersonic BrahMos 1. Again, in open sources, there are some discussion that this could actually be Zircon in disguise. So the Russians have got a Zircon missile, and they're saying widely, again, from open sources, that there are some similarities. So the discussion has really come along that this could actually be Zircon, an export version of Zircon. How accurate that is, we don't know at the moment, but they're currently doing quite a lot of work together with Russia. Another little project that they've done, and again feeds quite well into our discussion about test capabilities or flight test capabilities, is this one. Their HTDV, their Hypersonic Technology Demonstrator. And again, for this particular case, it's a scramjet-powered vehicle. So it was launched by a Afghani-1 ballistic missile and tested. The first test was not successful. A later test was. The interesting thing about this is comments have been discussed about future development for this system and how this could actually be used as a carrier vehicle to carry either other ordnance and things like that. What is interesting from a technology development point of view, a lot of this is homegrown. Okay, there is some Russian input. There is some input from other countries as well, but a lot of the work has been done by India. And again, India has been developing a lot of their hypersonic capabilities, not just test, but ground-based as well. Lots of new wind tunnels, new projects. Again, mainly through fear of what China has or has not got. They're trying to catch up. So even though this only flew powered for, I think, 6 seconds, it's their first scramjet test of their own engine. And as we said earlier on, those 6 seconds of actual flight test data, usability, is actually worth its weight in gold. So first successful flight in September 2020. So the US response. So these are only 2 of the hypersonic programs that the US are currently focusing on. They are doing quite a bit to try and not necessarily catch up, but to try and move their hypersonic work forward. I think in the press there was a lot of talk about the avant-garde in China, their hypersonic programs being a bit of a Sputnik moment for the US. I don't really think it was, because the US does have past hypersonic experience, things like HTV2 and things like that. But anyway, these are the 2 that they're working on. AGM-183, which is an air launch system, hopefully will come in, or they plan to have it in operational over the next year or so. So that gives you a bit of the background, but this is a challenge. Okay, so this is just an illustration of some of the aerodynamic problems that a vehicle would experience. So again, this is a simulation done on the HTV2. This was actually from a Chinese paper. So they have paid very close attention to what's been published online and have actually used information to try and validate their own design expertise, things like that, the vehicle. But it shows you some of the things that a ground facility, wind tunnel, okay, or CFD would need to try and model. Now, although CFD is coming a long way in terms of computing power, solving power, it still has problems trying to look at all of the flow physics. So, in terms of challenge, So if we're talking about a vehicle design, whether it be something like the X-43, X-51, our glide vehicle, whatever it is hypersonic-wise, we've got to think about the design, we've got to think about trying to get all of that equipment into a vehicle that's going to be constrained in terms of its physical size, okay, because of the carrier system or the booster vehicle that it's on. So trying to get a good efficiency from a volume point of view, obviously aerothermal issues. Performance, are we able to have the materials that will handle the heating and let us operate at Mach 20, 15, whatever we want to try and get to. As we need to try and develop flight vehicles, it then becomes more of an interest in terms of guidance and control. And again, you can only really test your guidance and control systems for these types of vehicles if you've actually built something and flown it. Okay, the guidance and control systems will be a lot different between our standard air-to-air missile compared to our hypersonic cruise missile or our HDV, whatever it may be. So again, we need to think about guidance and control. TPS, or thermal protection system, and also materials. So again, when we go back to capability, not for any capability, but as we're talking about the UK, we've got to think about material selection, and I should really point out manufacture. Things like producing the airframe, okay, thinking about what happened to the US program, even the smallest sort of detail or lack of detail or fault in any sort of manufacturing that vehicle may have could end up causing the loss of said vehicle. And also if we're thinking about something like a cruise missile or something like that, propulsion integration, what you should really think about is things like Avantgarde and the DF-17 that we've sort of briefly looked at. These are just the first generation of these systems. Okay, they're going to be worked on, they're going to be updated. Okay, they're not just going to be sitting still. So we need to think about how we can do that. And again, computational models and things limited accuracy and validation. And we've also already said about ground test facilities. So if we talk about a UK perspective now, what would we want to do? Well, we'd actually like to have a capability where we can develop and test key technologies, okay, how they're applied, how they will be operated, and also their applications. We've talked already about skill development and retention. So again, thinking about how we can increase the skills within the aerospace and defence sectors. Okay, having a flight test program, examples that we see in a moment, could be used to help, recruitment, retention in those sectors. And also, more importantly, gain practical experience, not only in hypersonic systems, how they're designed, but how they operate. What challenges will your opponent have to overcome and still face to field such systems? Okay, so we can look at it at both angles. So if we talk about sort of the UK side, so the UK does have Hypersonic Experience. I've seen several of you in the audience, and I've worked with you, so I am aware of we've got some Hypersonic Experience who have contributed to a number of, if you like, studies and projects. Okay, so we're not starting from a blank sheet of paper. We've got elements there. There are a number of organisations within the UK that are developing novel technology, whether that's for specific programs now or their own commercial projects, things like reaction engines, Rolls-Royce, etc., etc. If we then think about academia, because we said, well, there's another point in terms of academia, there is an active research community within the UK. However, this is quite small if we compared it to US equivalents. However, I'll bring that is, even compared to the US is still, in terms of publications at least, and this is what this graph shows, so the red line actually shows the number of hypersonic papers that were presented in the 2017 AIAA conference on hypersonics and space planes. So you can see that, you know, China's done well over 250 papers now. This may be controversial to say, whether all of those papers are useful or not, I don't know. I've not read them all. But nonetheless, it does prove that they are very active in that area. Now, whether or not this is the same trend has still continued for the following conference, I'm not sure. However, they are very active in terms of this. So we can say at this point, the UK's got hypersonic experience. We've done some work in the past. We're currently working on projects. We have got a small active research community across a number of academic institutions. So, main point that we need to think about, because sometimes I think the general public thinks that the UK is not doing anything and is not being active. There could be a reason for that, obviously, the nature of the work, okay? But we are not starting from a clean sheet of paper. So from the Science and Technologies Facilities Council, okay, report, currently in the UK there are 7 hypersonic wind tunnels, and they're located at 4 institutions. Now, of those institutions, these are the main research areas that they're looking at. So aerothermodynamics, boundary layer, transition, so yes, ticking a box for flight test. Intake performance, yes, again, flight test if we want to do air breathing systems. Cooling, useful for either of the systems, but not only the vehicle, but also the propulsion unit itself. Materials and also computational modelling. So there are elements that the UK is quite heavily active in. It's the last bit, it's putting this into a vehicle that flies or can be flown is where we are sort of stuck. So this is just, I was trying to put together what an organisation, not really an organisation. Originally I was going to call this section UK Hypersonic Initiative. I was thinking, well, how could this be put together? What sort of structure could it formulate? So, thinking back to our capabilities, we've got a number of technical areas that we might want to pursue. Okay, we've now included guidance, navigation and control, because obviously we're going to need that for our vehicle. We'd have technical groups which would comprise of teams of both industrial partners and also the academic institutions that would liaise together. It's a similar sort of approach that's done in the US. And the aim of that would be to probably do fundamental research. So again, thinking about, as we said, boundary layer transition, thinking about intake performance, things like that. So we'll have some fundamental research, which we can then move on to the next sort of series. Again, thinking about technical groups, concentrated more on doing a little bit more vehicle design. Okay, so we've moved, if you like, from the conceptual phase of different components more to the vehicle design. And it's this part that another sort of stream comes into play. So again, from our end users, other stakeholders, we're going to need some requirements and constraints which would feed into our vehicle and also technology evaluation. But as I said earlier on, these are very complex vehicles, okay, and if we want to get them to fly, or build them, test them, we've got to think about integrating all of these elements, all of the output from these technical areas, these technical groups, into one single vehicle. So a lot of systems engineering, thinking about design, modelling, testing, and also evaluating. So again, now focusing on, where possible, doing tests on a complete configuration. Again, trying to use the capability that we've got available to do this. So there might be sort of gaps, but we'd have to think about how we can sort of overcome those technical areas. So really we're looking at research evaluation and very heavily, as I said, on systems engineering. Okay, if we can get that right, then we can try and have a finalised vehicle concept. Okay, so it might be ready for flight. We might even also, at this stage, so this middle stage, thinking about how we're going to actually build this. There's a lot of the, I wouldn't say problems, but a lot of the things with regards to engineering, especially from an academic point of view, is you can sit in front of a CAD screen and design whatever you like. Okay, the problem is turning that concept into something that can be built, whether it's a full-scale vehicle or even usable, say, wind tunnel models. Okay, you've got to think about how that CAD, that design element, can translate into physical hardware. And this is really feeds in, again, as I said, to test capability. So it's not just being an intelligent customer, as they say, although that's part of it if you want to buy in technology. But you need to think about how that works as one cohesive unit. So if we've got through the systems engineering, thought about our test and evaluation phase, and come up with a concept. Here I've just used the X51, but it could be anything. It could be a glide vehicle. It could be just a scramjet engine that we want to test. Okay, anything that you need. But we need some process to help support that flight test capability. Okay, in order to, as I said, contribute towards hypersonics, but also develop UK capability and knowledge within that area. So in terms of CADMID, so here in terms of concept, well, fundamental research. Here, equivalent would be research evaluation. In service, well, let's fire it and see what happens. Get some useful flight test data, and also disposable. Well, either recoverable, I'll come on to that in a moment, or a standard sort of finish to most of these projects, which is they either end up in the ocean, or for things like the scramjet tests that are done in Australia, out in the outback somewhere. Okay, so this is, if you like, a sort of cycle that you could apply to a sort of flight test capability. So what options do we have in terms of the UK? Well, if we want to do a national programme, where, as I said, we're not starting from a blank sheet of paper, there are some gaps that we would need to try and address. Remember, I guess, in terms of heavy-duty hypersonics work, the UK has, not done a lot of that for probably the last 30, 40 years. Okay, so in terms of that experience, we'd need to address those things. One is obviously ground test facilities. So do you go to the expense that India and China are doing and spend an awful lot of money in building new hypersonic tunnels? Launch sites to conduct the flight tests. Now, if we were talking about this probably 20 years ago, I would say that poses a bit more of a problem. However, with the UK launch initiative done by the Space Agency, you may or may not be aware that there are currently a number of spaceports that are planned to be located around the UK. So whereas, we would also have to think about doing flight tests from a sort of launch site that we didn't have, now that's not so much the case, and also initial costs. So from a national programme, we would have a little bit of a hill to climb. So again, this gives you the indication of location of some of the spaceports that could be used for a flight test programme or flight test capability. Other aspects, so there's a lot of work going on in Australia, again looking at scramjet propulsion. This is something that has produced quite useful work and could be something that the UK could do or could contribute to. So maybe initial development of a similar sort of program. However, really, if we're talking about hypersonics, a joint program would probably be the way to go. So again, if we can join a flight test program like the one shown earlier, or with the US, we'll gain flight experience relatively quickly. We'll have technical and sort of cost sharing as well. So depending on what the program is, there might be interchange between the partners. There was a recent announcement last week about the UK joining a US and Australian hypersonic program aimed at looking at developing missiles. So these are sort of scramjet-based missiles. Now, it didn't relate to this specifically, but this is the current program that Australia are currently doing with the US. It's this Southern Cross Integrated Flight Research program. So this could be a way into that program. The UK, US, Australia announcement was thinking about looking at hypersonic missiles being launched from tactical aircraft. So again, small scale, relatively small scale missile systems. So again, for this would be a good way that using the capability that we've already got, we can feed that in to these programs based on the community that we've already got. Other joint programs, well, we've got a long relationship between the UK and France in terms of missile development. So the next one along is Future Cruise Anti-Ship, although, whether or not a partnership could be developed in terms of hypersonic systems and a flight test capability, I would imagine is something still to be discussed or confirmed. So what options for the UK? If we want to move away from cruise vehicles, because the other area of concern or interest is hypersonic glide vehicles, again, we'd have to do a joint program due to lack of suitable boosters if we're going for vertical launch. Okay, for a glide vehicle, a lot of the vertical launch sites that are planned for the UK, many of the launch vehicles that would operate from there will not have the payload capability to carry a glide vehicle at the moment, but whether or not that capability develops over the next few years, we'll have to wait and see. So any sort of HGV would have to be a joint program. If we can contribute a UK element of that, we could use some horizontal spaceports, so doing an air launch system. Okay. However, we could also do some work similar to the Australians, do some scramjet test vehicles and things like that. And I think for an HGV program or a scramjet cruise missile program, there is some capability that we could put together to test these types of vehicles. And that's just an image I got from Aviation Week about an example sort of glide vehicle project, or UK-US glide vehicle project. So far in the discussion, most of the work, all of the systems that we've seen, at the end of their test, they are thrown away. Okay, so the question really is, should we consider doing a recoverable or reusable system? Should this even be a consideration? So if we've got a system that's recoverable, again, I think it will provide really useful information in terms of visual examination of the complete vehicle and also specific components. So again, you can find out if your injectors have worked the way they had, if it's for a scramjet or your aeroshell, on the leading edges has held up as your code has predicted it would do, and also from the production side. So we can have a look at some specific components. Again, we can feed that into our validation of design code, CFD, simulation, that sort of thing. Again, an insight on how the operating conditions have affected this vehicle, because we might spend lots of money building these HDVs or cruise missiles, and then when we come to actually deploy them, we might find that because we haven't thought about some of the actual physical characteristics of their flight, whether that has a negative or degrades the capability of said system. So again, we can have a good indication of what the vehicle has experienced firsthand. Again, if we want to have a recoverable system, we can have an idea of what it means to have these systems in the field. Okay, the Russians might have Avangard or Chinese DF-17, but what does that actually mean from an operational perspective? Okay, what does their support need to do? And what sort of operational problems need to be overcome? The other system for if you imagine for a glide test vehicle, how do we defend against these? How do we track them? If you've got your own glide test vehicle, you could do launch it, track it, okay, get it to do all sorts of things, and use that to help develop your own sensors, etc., okay, to try and counter some of these sorts of systems. So I'll give you just a little scenario. So this is a very rough exercise talking about supporting an HGV program. So it's going to be air launched from one of the spaceports to a set location where it's released, ignited. It will then fly off on its trajectory. It will take us up to the Hebrides range, where we can then do our actual flight tests. If we want to have the capability to reuse it or recover it, there are options available. Or we can just do whatever all the other previous tests have done and crash that right into the sea. But again, I think doing that approach is a little bit short-sighted in a way because of all the potential benefits of physically seeing something yourself and how it's behaved. So this gives you an example of how a spaceport, the infrastructure could be used to support a glide vehicle. This is just a very simple case done just to, for the purposes of discussion. I'm sure that, a project like this would go into a lot more detail than what we've done on this initial sort of, if you like, trajectory analysis. I better finish up. So in terms of test capability, the UK does have capability, okay? However, if we want to go down the UK-only program, we're going to have to put a lot of money in, a lot of investment. So the UK probably only program might be a little bit beyond our means. Whichever path we take, I think it needs a commitment by, say, the government and also the end users to what this type of system would need to do. Recent developments, as we said earlier on with the announcement with Australia, has indicated this. But I think it's got to be sustained. We need to get out of this continued peaks and trough cycle. Otherwise, we're not really going to get any further forward. Joint program supported by the UK would be the most practical way forward. Remember, we've now got, with the possible use of spaceports and people operating from there, something more to bring to the table. So again, for a joint program, it depends whether or not the UK wants to see itself as a Tier 1, Tier 2 or Tier 3 player, similar to what the F-35 program has shown. Okay, what more could you bring to the table and get more involved? And basically, what I'd like to sort of have you take away from the lecture this evening is we need to be proactive to develop centres of excellence based on what we're good at, what capabilities we've got now, but how to take those further, thinking about the system side, the integration side, and how they can play a key role in future programs. And again, establishing the UK, as I said, as a tier one, etc., contributor to joint programs. And you'll be glad to hear that's the end from me. I would just like to say, before I hand over to David, please come, I'd be very interested to hear your opinions with regards to putting together a white paper. So anybody from industry or academia, please come and see me. David.
Thank you, Malcolm. I'm sure you'll all agree that was a most interesting lecture. Could I ask any questions be addressed through the microphone standing over there? Excellent. And it's the longest route from table to the mic. I appreciate that, but thank you.
Good afternoon. Yeah, thank you very much for an excellent brief. A lot of the points you've touched on chime with my thinking at the moment, and maybe we can have a talk about that a little bit later on. In terms of moving forward from a UK perspective, though, and all the issues you've outlined, what would you consider the quick win would be for the UK from a UK sovereign perspective? And also, how do you think we could unlock a collaborative effort, noting that collaboration is often a two-way street, so we need to have something to offer for something in return?
Well, in terms of the two-way street, I think that we do have the experience, we do have some knowledge within some of the areas that I covered. I think you're right in terms of joint programs. You've got to be careful because in the F-35 project at the start there were issues with sharing code and things like that. What I think we need to do from a UK perspective is always keep in mind IP, because IP gives you the freedom to operate. So from a UK sovereign perspective, I think the quick win would be to probably join a test program similar to what the US and Australia are doing. Now, whether or not it's in that Fire project or not, I don't know, but that will be the quick win. But I also think we can't 100% rely on our partners. We always have to have some knowledge, and it comes again to be how intelligent of a customer do we want to be. And again, if we've got some of the IP, in a way you've got freedom to operate, and you call the shots. I think it's really up to government, because they are the ones initially that are going to have to foot the bill for these types of things, to find out, whereabouts they stand, and are they willing to move forward. What I would say, and I didn't really say it at the start, 20 years ago, hypersonics and launch vehicles were taboo words. They were words that were not spoken of. Hypersonics and launch vehicles were done by other people. We don't do that sort of work. However, fast forward 20 years, we now realise that we need to develop these sovereign capabilities, not only in terms of launch vehicles, but also for hypersonics, for defensive capabilities. So I think going back, it's really linking up the stakeholder, and the first stakeholder to try and give us a good idea is UK government and MOD.
Thank you very much.
Thank you. Any other question? Please, if you could use the, thank you.
Hello. First of all, apologies for being late. Got the timing wrong, as usual. You talked about 20 years since we talked about hypersonics. but way back in the mid-70s, Farnborough certainly had a hypersonic tunnel. And as a student, I worked on what was called a high-wing shuttle orbiter. The main object of this was, in fact, to get, as reading your papers, get a bigger cross range than the US low-wing shuttle. So I'm just curious as to, does that mean nothing's happened since? I mean, okay, I'm going back to the mid-70s, but certainly there was hypersonic research going on then. If for no other reason than obviously for re-entry vehicles.
I mean, there's always been elements of hypersonic work going on. I think the UK, unlike, say, the US or other countries you could mention, that work is sort of kept quiet, whether or not because it's not on the same sort of grand scale of those countries. But again, it goes down to, you know, when is hypersonics in vogue? So the 60s, 70s it was, the 80s it sort of was with HOTOL, but then HOTOL, with all of these sorts of programs, unfortunately HOTOL was in the unfavourable position that there was a hypersonic system and it was a space plane, i.e. a launch vehicle. And the policy at that time of the UK government was, we don't do launch vehicles, so we're not interested. And it's been that sort of process, basically. I would like to see, you know, I think having some sort of program like the Australians would have, even from a purely academic side, would be useful. It would be useful to, I guess, show the world what we're capable of if we want to join a joint project. Again, it's what can we bring to the table. And if you're not being seen to be proactive in these areas, then when you come to join that program, obviously they're going to say, well, what can you bring? Where are you going to be? Are you going to be a country that, you know, makes it happen, watches it happen, or wonders how it happens? And we have to decide where we want to be, or do we just want to buy everything off the shelf and maybe have a few people, you know, that can service them, operate them, and that's all we want to do. So yeah, it's, as I said, it's up and down, and hopefully with the announcement last week, that might change.
Thank you.
I was hoping with this microphone it would deter people from asking questions.
Sorry.
Certainly not.
Two questions. Could you give us a little more information about the Australia-US thing, about what they're doing there, and how involved the UK is? And also, what do you plan to do with this white paper? What are you trying to achieve, really? Yeah.
Okay, so the Australian program has been running for a number of years, and the initial project was High Shot. At the time, the UK was involved in doing some scramjet work as part of that. That then morphed into a follow-on program called High Cause, again heavily developed with the US and Australia, mainly looking at scramjet test vehicles. Then that went to High Fire, again scramjets, however they also launched glide vehicles, etc. So that's how that's developed, and obviously this Southern Cross is an extension of that. In terms of the white paper, well, I would like the UK to get more involved in hypersonics. You know, I would like to show or tell that we have got the experience, we have got the knowledge out there to apply it to these types of programs. And it's really a white paper to outline that. But obviously, you know, using this as a forum to try and engage with academia, other academic institutions rather, and industry to try and make a white paper more viable rather than it looking as though it's been written by some fruitcake, so to speak. You know, that's the idea, and hopefully using that white paper to try and say, well, you know, actually we might be able to do something with this. Maybe not as a UK national project, but certainly as a high-level tier contributor to an international program. That's how I would like the white paper to go.
Just wondered if you might be able to put a sort of sum of money on how much it would cost to actually get something usable out of something like this. And sorry, presumably we'll be heading down a weapon path rather than some kind of... anyway, so how much money would it cost to actually produce something ultimately, and also the research program? I think you gave a number the other day of like something like 58 million for certain other programs. So how much would something like this actually cost?
Right, so for example, the Australian programs from the... I'm trying to think, I think it might be in the Australian Air Force or something like that. They've quoted that their program cost $58 million. That was for their scramjet tests. Now that's quite cheap. Again, having the experience that they had from the previous projects has obviously helped with that, and also building a relationship with the US. In terms of a UK hypersonic capability and a figure, I have not come to that conclusion yet of how much that would be. But I think even committing that sort of funds, or partial of those funds, into another, say, UK, Australian, US program would provide some very useful feedback for quite a small, or relatively small input. I think for a UK, when you ask about a UK, it depends what level. I mean, if we're talking about building new wind tunnels and things like that, you're talking a lot of money. Because it's not just building the tunnels itself, it's where you're going to physically locate them, who's going to operate them, etc., etc. And also, the other thing that we need to point out is, you know, if the UK is developing this, you need a constant sort of projects, or work to justify that sort of vast expense of doing new ground-based facilities. Might be a case of just seeing what's there, and maybe some upgrade of what we've currently got might be a good first stage, I think. But in terms of sums of money, no.
Any other question? If not, I'd just like to thank Malcolm for, as I say, extremely interesting lecture.
Thank you.